Hello, everyone. You are welcome to today's session. Today's session, we are going to continue from where we left off on the lesson on trigonometry, trig for short. Okay, in our previous lesson, okay, that is the lesson prior to this, the immediate lesson prior to this, we looked at various diagrams and how best to use the diagram to answer, okay, questions related to trig. Okay, today's lesson will not be an exception. Okay, we are equally going to look at diagrams, okay, of different nature and how best to employ whatever that we've learned under trig in dealing with it. Okay, so as usual, okay, please stick and stay with me whilst we have a wonderful, okay, session together. All right, so let's look at question 4. And for some reasons, I'm going to shelve the question 4. Question 4 and question 5 and maybe question 6 are quite related. So if I shelve question 4 and we do question 5, question 6, okay, when you come back to question 4, you should be able to do it. And the reason why I'm shelving question 4 is basically because of this, okay, angle of elevation. Because we haven't done, okay, that, angles of elevation and depression, okay, that's the more reason why I am encouraged to, okay, shelve this particular one. Other than that, we can solve this question, but solve the I and leave the I. Okay, so take note. So if you have time, after going through the other questions, we'll come to this, back to question 4. That is, if time permits, then I'll walk you through how to get the I, but I won't do everything, okay, from the scratch, and equally the I. Okay, if time permits. Okay, so quickly, like I said, I am going to, what do you call it? Okay, so skip this. So let's look at question 5. All right. So you can see that it's similar, basically. So let's read the question. Okay, or we should do the question 4 and do only the I. I think that can also be. We should do only the I and leave the elevation. When you are walked through the elevation, then you go back to it and try. So I think we can do that as well. Okay, it's our class, so we can decide what to do. Okay, so let's see. Let's read this particular question and see whether the information here, there is something that we need to add. Okay, so in the diagram, XY represents a street lamp. So where is SY? So this is a street lamp. Okay, ST represents a boy standing 6 meters away from the street lamp. So this is the boy 6 meters away. So you can see the distance. Okay, TZ is the shadow of the boy cast, okay, by the street lamp. Okay, so, okay, because there is a light source here, okay, if the boy is here, there is going to be what? A shadow that will be cast by the boy. So the shadow, you know, will start from the foot, okay, of the boy up to, that's where the boy is standing, up to this point. And that's what we have labeled what TZ. The question is saying such. Okay, then the height of the boy is 1.5 meters. So the height of the boy is 1.5. So that's the height. And the street lamp is 4.5. I think it's supposed to be 4.5. So let me put the 5 there. All correct, my professors. It's a typo. Okay, an omission.
Please.
Okay, 4.5 meters high. Okay, so that has been catered for. All right, then what are we supposed to do? Okay, is we are giving, so it means this one away. The boy was standing 6 meters away from the street lamp. So that's the more reason why Y, T or TY is 6 meters. The distance between the boy and the street lamp. So that's the information that we have here. But like I said, we are going to use this information to find TZ. So we want to find, okay, the length of the shadow of the boy. You get the point? Because TZ represents the shadow of the boy. All correct?
Yes, please.
Okay, so remember, the boy basically will be taking, so this indirectly is a vertical line. So we'll meet this at an angle of 90. Okay, then this will also be your street lamp. Okay, will also meet, okay, your horizontal line, which indirectly will be the ground at an angle of what, 90. So if you look at this picture, let me see whether I was supposed to go up. Okay, so where I have, so I should have taken the question from here. Okay, take note, because I remember drawing the triangles there just to save time. Okay, so the other one will be the continuation. Okay, when we exhaust this and we need more space. So if you look at this diagram, okay, Prof. Caroline, hey, am I
Mr. Hartman,
recording?
please.
Yes, I am. I'm recording,
Mr.
right?
Hartman,
Yes,
yes,
okay.
please.
Mhm.
Mr. Hartman, please, when you finish writing the solution, please answer us under it. You're supposed to write a question number.
Yes, I'm now with this one because I didn't want us to go back. That's the more reason why the diagrams. I'll come to what I will write. Okay, manually. I'll be using my, so I will do that. Okay, so I'm going to add to what we have. Yes, but it's good you have. So it means you know. Okay, your stuff. So remember, after solution, what do you write? The question number. So we have ignored the question, just as Prof. Caro said. So the question number will be there. And you can also say that, you can see that I didn't introduce the vertices. But my question that I was asking before coming to this, okay, I mean, introducing all that I need to introduce, was that how many right angle triangles can we get from this? From the main diagram in the question. How many? Two.
Two.
Okay, so that's what I have done here. You remember the last meeting, I would take it and come and draw. But because today I want us to save time, I've already drawn all the triangles, okay, before. So in that case, what do we do? I will just come and label. So this one will be X, okay, Y. So this will be the bigger triangle, X, Y, Z. Okay, and the smaller triangle, the right angle triangle will be S, okay, T, okay, Z. Hope you are with me, my professors.
Yes, please.
Okay, so remember, don't forget to indicate the 90 nature of this, the 90 nature of this. Okay, and the more reason why I did this, the other one, okay, in our previous lesson, I took, okay, the annotation and the diagram. So the diagram from the annotation, okay, of the, what do you call it? What's up here? And when you do that, immediately you move on to the next page and you even end the class, all the diagrams will go. So now I pick the diagram from the original source, which is the PowerPoint source. So, okay, after everything and I end the class, the diagrams will be there so that I can send you the PDF or, yes, version of the PowerPoint. Okay, so quickly, that was just by the by. So now what do we have? Let's try and indicate all the length that we have or any other information. So we brought the, or introduced the vertices. Now let's see. We know this distance to be 4.5, Abby. XY we know is 4.5 meters. All correct.
Yes, please.
Okay, we know ST also to be, okay, 1.5 meters. Is that not it?
Yes, please.
Okay, and TZ is what we are looking for. So let's represent TZ by X. I hope that's fine with you. So this is X.
Yes, please.
So if this is X, then we know YZ will be what? What will be the length of YZ?
6 meters.
No, 6 meters is YT. So look at this. If this is X, it will be what?
6 plus X.
6 plus X meters. Do you agree, my professors?
Yes, please.
Okay, so I'm going to write that one also here. So this will give me 6 plus what? X. Okay, so meters, we can choose to, okay, so let me attach the unit. This will be X meters. Okay, then, okay, this, let me put everything in bracket and introduce the meters there. Okay, so if you are with me, then we are good to go. Somebody can write 6 meters plus X meters is the same thing. Okay, all right, so at this point, we are in a comfortable lead. Okay, remember the advice. Okay, what are we looking for? We are looking for X. Okay, this is what we are looking for. Okay, the TZ. And the advice is anytime, if you look at this particular triangle or these triangles, remember in our previous lesson, I told you that anytime you have a question and you are dealing with it, check whether the question, the diagram that you, okay, you were able to bring out of the main diagram, the diagrams that you're able to bring out of the main diagram, whether they share a common side. Okay, with this one, can you see they share, do you see these two triangles sharing a common side? Okay, so let's do that together. Okay, so the size of this triangle will be, the size of this triangle, remember I said the main reason why we are meeting is to take time and go through this. So let's do, so the side here will be what? The possible side will be X, Y. Hey, let's go. Hey, for this, the first one. XZ. My professors, are you there? Then YZ.
Yes, please.
Okay, so if you are matured, you do this mentally. I want us to everyone to be on board. If you come to this, we have ST, okay, you have SZ, okay, and you have TZ. Okay, any common side?
Sir.
No, sir, right? It's a big no. No common side. There is no side here that you can find here. Okay, and vice versa. So in this case, what do you do? So this is what you are going to do. You don't have a common side. So what I gave you, form equation based on the common side will not work here. So does that mean we can solve, okay, for x? And the answer is a big no. We can solve for x, but we have to be more analytical. This time round, if you look at the diagram carefully, you will see that these two triangles, instead of sharing a common side, they share a common angle at z. Can you see that?
Yes, please.
My professors, is everyone with me?
Yes, please.
Okay, so let's call this angle theta. The angle that they share, okay, theta. Okay, so let's call this angle also theta. Okay, so it means now instead of common side, they share a common angle. So if you are forming an equation, originally if you have common side, you form an equation linking the common side. So with this time around, we have a common angle. So we have to form an equation linking what? If it's common side, equation linking common side. So common angle would be equation linking what?
Common angle.
Common angles. I hope you are with me, my professors.
Yes, sir.
Okay, so this is all that we are going to do. So if you are going to take the first, okay, right angle triangle. So as usual, you write from, just as we've been doing, the first right angle triangle, and the right angle triangle is what? What is the name? X, Y, Z. X, okay, Y, okay, Z. From that, I can see that if I look at this angle, I know the opposite and I know the adjacent. Do you agree?
Yes, sir.
Okay, so which trig ratio should come to mind?
Tan.
Tan. Okay, so can I say that from this triangle, tan my angle? And what is the name of my angle? Theta, is that not it?
Yes, sir.
Okay, will be equal to opposite, which is what? 4.5 over the adjacent, which is 6 plus x. Do you agree?
Yes, please.
Okay, so, okay, are you all on board or I should come again? My professors, who wants me to come again?
Please come again.
From where? From Portia.
Sir.
Patricia.
Okay, no, I've seen Portia's hand too. Up.
Yes.
I should come again, right?
Yes, please.
Okay, but from where? I don't think it's the whole show.
Yes, not the whole show.
It's not, so from where?
That's
Is it from the from?
yes, please.
Okay, all right. Okay, so from this, you can see that this is your angle, is that not it? Okay, so this triangle, this is your hypotenuse, H. Okay, then because of this angle, relative to this angle, this is the opposite and this is the adjacent. Do you agree?
Yes, sir.
Okay, all right. Prof. Angie, your hand is up. Any issues? Mm-hmm. Prof. Angie, how may I help you?
I was perpendicular to the YZ, the line YZ.
You said what?
Or is it because it was a street light?
Yes, you know that
Like,
usually.
you assumed it was.
No, it's a correct assumption. There is nothing wrong with that. You know that, okay, usually, I don't know, you know that usually street lamps are vertical. Is that not it?
Yes, please.
Okay, and human beings too, when you are standing on the floor, okay, or on the ground, okay, you stand vertically. Is that not it?
Yes, please.
Okay, so it goes to reason that, okay, if the ground is horizontal and these two, okay, the pole and the, what do you call it, the boy, okay, the human being, okay, vertical, they will always meet at an angle of 90. Do you get it? Prof. Angie, do you agree now? Oh, okay. All right. So I think she's having network issues. Okay. So now, Deborah and Co. So from here, we said this is your angle. Your angle is theta. Okay. And with respect to theta, this becomes the opposite and this becomes the adjacent. And we agreed from the beginning, before we started doing this, that we are going to form an equation linking the common side. It's a common angle in this case, forgive me. Okay, so now with respect to this angle, opposite and information is given. Okay, the adjacent also, I know a bit of an information. With this side, I don't know any information at all. So it means I'm going to use, okay, tan, because tan involves the opposite and what's adjacent to one. Okay, so I don't have to take any trig ratio that involves what? The hypotenuse, because I deficient in terms of information. So car which involves hypotenuse should be out. Okay, which also involves hypotenuse should be out. So sine and cosine should be out. And ultimately, okay, tangent will be the one that must be in play. Afa, all correct?
Yes, exactly.
Okay, great. So we know tan of this angle will be equal to opposite, which is 4.5, over the adjacent, which is 6 points. SS plus S. Remember, I've told you, when you are substituting, okay, ignore the length, the unit, because they will cancel in the long run. Okay, so now at this point, I can label this one as equation 1. Okay, that's my first equation. Now I come to my second triangle for my second equation. So from, okay, the second right angle triangle. So those who were saying you didn't really understand after explanation, you said you are fine. I will ask you to help me or convince me that indeed you are fine. So triangle STZ. Okay. All right. So, okay, proportion. Okay, this triangle with respect to theta, what is the opposite?
Please, the opposite is 1.5.
Very good. And what is the adjacent?
This x inside.
X. Okay, so now you can see that, okay, I know opposite, I know adjacent. This time again, the hypotenuse is deficient. So what do? I will use tan. Okay, so tan, again, my theta, okay, will be equal to, from that triangle, it will be 1.5 over x. Do you agree, my professors?
Yes, please.
So that
Yes,
becomes
yes.
equation what? 2. So we know equation 1 must be equal to equation 2, Abi.
Yes, please.
Okay, must be equal to equation 2. Because if A is equal to B, like I stated, maybe some of you were not here, and the same A is equal to C, then it means B must be equal to C. So if A is equal to this and the same A is equal to this, then it means this and this must also be equal. Apa?
Yes, please.
Okay, very good. So now, okay, we will go, and this will be too short to take a line. So comma, semicolon, or comma, column, something must, okay, separate that from whatever you are going to write. So I'm going to get 1 is equal to 2 will mean that 4.5 over 6 plus x, okay, should be equal to, help me, 1.5 over x. Is that not it?
Yes, please.
Okay, so now you can see that we have a simple equation at hand, equation in x, and we should all be able to solve this equation for x. And we know if you find x, we know tz because we represented tz by x. All correct?
Yes, please.
Okay,
Yes,
so
please.
now this implies that what do we do? Cross multiply. So it will be 4.5 times x, which will give us 4.5x. That should be equal to 1.5, okay, times this is a binomial. So let's put the whole of that in bracket. 6 plus x. All correct?
Yes, please.
Okay. All right. I'm hearing only Portia's voice, so she's the one speaking on
Yes, please.
everybody's. Okay,
Yes,
okay.
please.
All right. So you are fine. Okay. All right.
Yes,
Okay.
please.
Prof.
Yes,
Angie,
please.
are you back? Is your network better?
Yes, please.
Okay. So you're able to follow, right?
Yes, please.
Okay, so 4.5, okay, x, okay, will be equal to, let me write my x well, will be equal to, now let's multiply this, 1.5 times 6.
9.
9.
9, okay, so you get 9, then, okay, plus 1.5x, do you agree?
Yes, please.
Okay, so we are looking for x, so we collect all the terms in x on one side. So let's see, if I bring this one here, it will give me a positive result. So it means I have to follow the normal movement, this one to the side. If it would have given me negative, then you try the other one to move this one to the side. So now 4.5 minus 1.5 will give us,
3.
so it will give us 3x. Okay, I hope you are all with me. It's equal to 9. Okay, you write it again before you divide. Okay, over 3 over 3. Okay, so you get our x to be equal to what? 3. By it to be 3 what? Okay, centimeters or meters. Is that clear?
Yes, please.
Okay, so I'll write therefore x is equal to 3 meters. Am I right?
Yes, please.
No. X came by
No,
way of your
no.
own introduction. You cannot conclude with it. So be careful. Okay, all right. So now what do I do? Once I know X, I know my TZ that I was asked to find. So I can, from the beginning, whilst I'm forming this, I will know that I'm solving for I. So someone can come and write I here. Solution. Remember, I've told you any question number, any number that you see in the question, your solution must equally have that what number. In this question, you can see 4. Okay, 4 is here. You can see I, so I will be here. Or if you don't write the I here, you can come and write I where you are drawing your conclusion, but you don't write the 2. Okay, now write therefore, what was I asked to find? The length of TZ, okay, is equal to what? 3 meters. How far? All correct?